Okay, we're going to spend a good 6 or 7 minutes talking about potential energy. Now, I'm going to talk strictly about one kind of potential energy called gravitational potential. All right, there's also another kind of potential energy called elastic potential that deals with the energy of springs and elastic objects. Um, Often you also hear the energy stored in chemical bonds referred to as potential energy because it's stored. Okay, so potential energy really is any kind of stored energy, and then it branches off into the different types from there. Okay, so gravitational potential energy is created by the force of gravity. It's the stored energy that an object has when it has height. Okay, when it's away from the surface of the Earth. Okay, so an object that has height above the surface of the Earth has potential energy because it has the ability for the force of gravity to act on it. I can just see right now that I spelled force wrong. But anyway, as we said before, if you watch the kinetic energy one, that any kind of energy is a capital U when you're looking at equations. Okay, so the little g next to it will stand for gravity. All right, and it's a very simple one. It's the mass of the object in kilograms times the height of the object in meters off of the lowest point that possible, and the acceleration due to gravity of 9.8. You've seen that many times before. All right, and just like kinetic energy, it is not a vector. Okay, there is no direction to it. You just have a certain amount of potential energy. You have a certain amount of potential for the force of gravity to act on you and move you. Okay, so that's just a little bit about the equation itself. And just like kinetic energy, the units for potential energy is joules, a capital J. Okay, every kind of energy, no matter what it is, chemical or kinetic or electromagnetic or sound or whatever, they can all be referred to in terms of joules. That's why they are so interchangeable and can be connected so easily. All right, so why does the height matter? Well, the higher you are, the more work the force of gravity can do to you, the more it can change you. Okay, the more speed it can give you, and the greater effect it can have. All right. So the higher you are, like if you're at the top of King de Ka, which is the roller coaster at Six Flags that you see in the picture, if you're all the way at the top, the force of gravity has the ability to do a lot to you. You have a lot of stored energy that you can be released with movement. All right. And because the force of gravity acts downward towards the Earth, it's the height that matters and not the horizontal position or the horizontal movement of the object. It all is just about the height off of the lowest point, okay, which usually would be the ground. But that's another topic that we don't really need to discuss at the moment, okay? So it really has no bearing on horizontal movement, and potential energy isn't affected by kinetic, meaning it just deals with height. You have so much potential energy because of height, all right? It doesn't change based on the kinetic energy you have at a spot, okay? For example, if the roller coaster cart got to the top of the hill that you see in the picture in front of you, it has potential energy because of the height of it, okay? It could also have kinetic energy at the top if it was moving a little bit, but it still has the same amount of potential no matter whether it's moving or not at the top of that hill. Okay, hopefully that makes sense. If it doesn't, be sure to ask, and we can explore it a little further. And just like the kinetic energy video, I just want to give you an idea of some amounts. An 80-kilogram person sitting on the top row of Citizens Bank Park has the potential of about 31,360 joules. So that's a lot of energy stored up for gravity to act on you if you were to, unfortunately, fall from the top of the Citizens Bank Park, from the top row. 100-kilogram roller coaster car, which is about a 200-pound car, which would be about one car off of a train, on top of an 80-meter high hill, which is about as tall as if you've ever gone to Dorney Park and you've been on Steel Force. That's about 80 meters high on the tallest hill. Has potential energy of 78,000. Now that should make sense to you that that's such a large number, because as you fall down the hill, you end up with a whole lot of kinetic energy and a whole lot of speed at the bottom. So that large amount of potential energy you had at the top of the hill gave you the potential to do something else, meaning gain a lot of speed. Okay? I just want to do that so you have an idea of amounts, because sometimes when you do a problem, you don't really understand if 500 joules is a lot or a little. So this is going to try to put it into a little more perspective for you. So just a real quick one, like in the last time, a 2-kilogram camera dropped from the top of King Ka at Six Flags has how much potential energy at the time it is dropped? King Ka is 139 meters tall. It's about 420 feet, as I remember. Okay, so I want you to stop the video at this time. All right, try it. Go back to the equation on the second slide and make sure you're getting the correct answer. Okay, so stop, try it right now, and then play once you're done. So just to give you an idea of the work that you should have just done, potential energy is capital U with the lowercase g as a subscript, and is equal to mass times gravity times height. Okay, so you'd see we have a 2-kilogram camera, 139 meters off the ground. You should get an answer of 2,724.4 joules. Okay, now we could get more involved with it if we had time. Like for example, the amount of potential energy you would have on the moon would be different than what you have on the Earth, because the gravitational pull is different. Okay, that should make sense to you. We don't really need to do any practice with it in class, but that should just be something that makes sense, that the 9.8 that you have on the Earth isn't the same as on the moon or on Jupiter or anything like that. Okay, so that's another kind of what's called mechanical energy, because it deals with the energy of movement and position. All right, so we have kinetic now, we have potential, and then we're going to start getting into how do they connect to each other, and then how do they connect to every other kind of energy.